Good afternoon and welcome to Webinar Wednesday. Today we are joined by Julio Castro, Regional Sales Director at Pronk Technologies, and Jeff Goldstein, Pronk Senior Field Applications Engineer. Webinar Wednesday would like to thank our sponsor, Pronk Technologies. Pronk Technologies' mission is to provide innovative products to refine and streamline the biomedical maintenance and support process. Biomeds in the field need equipment that is portable, affordable, rugged, and reliable, and easy to use. Pronk designs and manufactures specialized diagnostic tools that are tailored to their needs. Pronk's innovative designs have been granted 17 patents worldwide. So for more information, please visit pronktech.com. Just a quick reminder about saving the date for our fall MD Expo. We're headed to the Mohegan Sun Casino Resort in Connecticut from October the 8th to the 10th. Join us for 3 days of education, networking, and the latest advances in medical technology products and services. For more details about that, please visit mdexposhow.com. Also like to mention that HTM Week is May the 19th to the 25th. It's a week that promotes awareness and appreciation of professionals who manage and maintain a variety of medical devices and health technology in hospitals, clinics, and throughout entire healthcare systems. At TechNation, we celebrate HTM professionals every day. But the magazine wants to do something special for HTM Week. Each weekday, one lucky biomed will win a $100 gift card via a new contest sponsored by Healthmark Industries. So how do you win? It's simple. Go to OneTechNation/HTM Week contest and fill out the form. Entries will be accepted through the end of HTM Week. Each day, a winner will be announced on social media, so please follow TechNation on Facebook and LinkedIn to see if you win. Okay, today's webinar is eligible for 1 CE credit from the ACI, and you can obtain your CE certificate by completing the post-webinar survey, which will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your 1 CE credit from the ACI, and you'll be able to download the certificate directly from your computer once the survey is submitted. If you have any questions, you can reach us at webinar@mdpublishing.com. Okay, let's kick off today's webinar by giving away one of our Webinar Wednesday 10th anniversary prizes. Today's prize is a $100 Amazon gift card. So using the questions feature on your dashboard, let me know the answer to the following trivia question. May is National Salad Month. What is the most popular salad dressing in the US? I'll reveal the answer and our winner at the end of the webinar. We'll be wrapping up today's presentation with a live Q&A, so please submit your questions anytime using the question on the webinar dashboard. As I mentioned earlier, our presenters today are Julio Castro and Jeff Goldstein, and they will be discussing fundamentals of servicing ventilators, key PM tests combined with the power of test equipment automation. So Julio, whenever you are ready, you may be.
Fantastic. Thank you, Linda, and thank you, TechNation, for hosting these great webinars. We appreciate the invitation to present information today, and thank you all for taking time out of your busy day to attend as well. We're going to cover a wide range of things today, starting with a little back in history, going back in history on evolution of mechanical respirators as they were referred to before ventilators, going over some of the critical subsystems or components that are important to service and do during the PMs, including going over some key preventive maintenance testing that, of course, you do each and every day, every month in servicing these critical devices. And then we're going to actually have a demonstration of performing some of these critical tests. We won't go through the entire PM in the interest of time, but we're going to go over some of the key critical performance tests that have to be done when we're servicing and doing PMs on ventilators. And then at the end, after the demonstration, we'll go over a couple of FDA reported incidents. Always feel it's important to kind of learn from the lessons of the past and learn from actual cases, case studies that have happened in the field. So we'll go over a couple of those. So positive and negative pressure ventilators have been around for some time. In the early 1800s, a gentleman had created a negative pressure ventilator. But in 1864, Alfred Jones was actually the first American to patent a ventilator that was designed somewhat like this drawing here, where you would be able to generate a negative pressure in this chamber here with the patient's head sticking out of the box. So not the most comfortable thing, but an innovative idea at the time. Not until in 1907, a name here you'll probably be familiar with, Heinrich Draeger, that created the first pulmotor. It was a respiratory device that was able to generate positive and negative pressures at specific volumes. So it's a really innovative device at the time that would allow us to do save patients and be used in field use. In the 1928, a gentleman named doctor named Philip Drinker created what was commonly referred to as the iron lung, and it's actually first used at Children's Hospital in Boston in 1928. And it became very much a critical device needed, particularly during the polio pandemic that happened in the 50s. So mechanical ventilation has advanced tremendously. A lot of new companies got into the ventilation field, including companies you're familiar with that develop a wide range of products that advance these devices, including advanced features that allowed different patients with different levels of acuity to be treated, including creating advanced modes like spontaneous timed ventilation modes, synchronized intermittent mandatory ventilation, you have adaptive support ventilation, and many other ventilation modes which allowed therapy to be set based on the patient's acuity level and really help improve outcomes on patients. So modern ventilators, of course, have advanced even more so, where you have a wide range of applications that can be set to and customized towards. You have your ICU ventilators, anesthesia, a lot of home use type ventilators, CPAP devices, ambulatory devices for patients in the field or in ambulances and that sort of thing. And these devices, of course, have advanced programming ventilation modes. So the ventilation modes and different settings that can be set for improving patient outcomes is really advanced as well, including now a number of ventilators have the ability to monitor particular vital signs, critical vital signs like pulse oximetry, SpO2, CO2 on patients. So they've advanced significantly. Just a basic diagram of a ventilator, which I'm sure you're familiar with, kind of outlined for us some of the critical things we need to make sure we're always servicing, even from the user level all the way through during PM service and repair. So this is a very rudimentary layout of the basic subsystems of a ventilator. You have, of course, your controls, your oxygen flow coming in from the outside with your control valves regulating that flow. Same with the air. You have your flow sensors for each particular channel, and then you have your mixing and your really precise blower that allow us to set an inspiratory flow value very precisely and set by the user, of course, to the levels that are needed for the patient to deliver the inspiratory flow to the patient. Of course, these systems and valves and pressure sensors and CO2 sensors and things, these are things that are critical to the performance of a ventilator and things that, of course, that we have to test during our maintenance and even clinical staff verifying these sensors are working properly. And then the same is true for the expiratory flow. We have to make sure we're testing these subsystems as the patient's expelling CO2 in the air out of the lungs, flows back through the ventilator through the expiratory flow and flow sensor to monitor that. And of course, you have other systems in there that allow us to kind of control that expiratory pressure through our PEEP adjustment, our positive and expiratory pressure controls here, so we can basically provide the therapy to the patient as needed. So very critical that all these systems are working properly and that are checked on a regular basis, as you know. So we have to do a wide level of service on this. I'm sure I don't have to repeat it to you. Following the manufacturer's procedure is important. These devices are somewhat very uniquely designed depending on their application. So it's not as if one PM procedure can apply to them all. So we have to make sure that we're always trying to follow the manufacturer's procedure as it's outlined. These ventilators have a wide range of tests that need to be performed, including system leak tests, which are critical. Filter replacements are very critical from the clinical use and even during the PMs, particularly in home care devices if you have to service those devices. In investigating and putting the presentation together and reviewing the FDA incidents, there was a lot of incidents with home care devices, mostly because you can't really have much control of the environment, and a lot of ingress of contamination into the ventilation machine because of bad, dirty filters or lack of replacing of filters. So these things, of course, are critical to always make sure we're maintaining replace at the proper intervals. Checking the user error logs in the ventilators can be a great tool, or a great tool, to make sure we're able to identify any possible errors that are occurring. Of course, if there's a patient incident, the error logs are one of the first places you go look towards to try to understand what could have occurred and kind of do your analysis to trace back what could have caused the problem with that device. So making sure we're taking advantage of the information there can be important. Alarm tests, we'll talk about that, and you'll see an example of it, how critical alarm tests are. Battery operation tests, we talk about battery operated devices. There was a number of incidents where the batteries failed to operate when power went out, or they were using on batteries, and it caused patient incidents to occur because the battery was not maintained at the proper intervals. And of course, we need to do our flow and pressure tests. So these are tests that analyze, basically test and verify that all those critical subsystems are working properly as we go through our PM. So what I want to show you next is an actual example of some of the critical tests that we're going to run on a particular ventilator. And we're going to go through just all the critical tests, not every single test, not saying some of the tests are not critical, but they're more straightforward. So we're going to kind of cover some things that will hopefully shed some light on how we can utilize and leverage the procedure with having the right test equipment, with the right kind of performance and features to help make sure we can test these devices as effectively as possible.
We want to go ahead and perform the key and critical test on a ventilator. And we're going to use this Philips V60 ventilator as an example. We want to make sure we follow the manufacturer's procedure and have all the proper test equipment. This means having an electrical safety analyzer. We're going to utilize the PROC safety sim to do all of those tests. We also need to have a flow meter that can measure pressure, and we're going to utilize the TSI Certifier Plus to do those tests. Of course, we need to make sure we have a test circuit, a test log, and all of our various adapters to make sure we're following and doing the tests according to what the manufacturer requires. We're also going to be utilizing the PROC Mobilize app, which you'll get a closer look at in a moment, which allows us to open and follow the manufacturer's procedure. And whenever there's a test requiring a measurement, be it a safety test, a flow test, pressure test, we can have those tests executed to the test equipment from the app and have those test results come back to the app wirelessly so that we can follow that manufacturer's procedure, collect our data all electronically. No need to manually write anything down. So it allows us to be more effective, more efficient to do all of our work necessary. So let's go ahead and get started. Just a quick introduction to the app itself. The Mobilize app allows you to customize the header information that will show up on the reports. You could customize the title, the facility, the technician. You have the ability to manually enter in the asset ID or to scan it using the integrated barcode scanner. And then we have various modes here. We're going to utilize what we call the checklist mode, which allows us to have various procedures that PROC has created that follow the manufacturer's testing requirements. And so we're going to utilize the Philips Respironics ventilator procedure here. But what we can do with the Mobilize app is we can utilize the scan function, and we'll go ahead and turn on the scanner now. We can hold up the scanner up to the barcode of the medical device, and it will automatically open up the checklist that corresponds to this device. So you can see it opened up the Philips Respironics V60 Plus ventilator procedure. And the very first thing it allows us to do is to configure the procedure the way we need to. So you can select information, what tests we're going to perform. You can also select what type of flow analyzer you're going to use. And you can see here we've selected the Certifier Plus 489. We could use the 490. That's their all-in-one flow meter as well. We also need to confirm what software version does the ventilator have and make sure the procedure corresponds to that software revision. So in this case, our particular ventilator is utilizing software Rev 3.0. So we're going to go ahead and select that procedure. And if we did not have an automated device that integrates to our Mobilize app, like the TSI Flow Certifier Plus, we could utilize we could select other flow analyzer, which will allow you to manually enter in the test results. But with this, the nice thing is that all of our test results will be automatically captured. So this allows us to configure that procedure. And you can see here, when you see the procedure, you'll see every step involved in that procedure. And you'll have a little I symbol here to the right, which explains added information pertaining to this step. In this case, when I click on that, it gives me a list of what equipment I need to make sure I do, when I have the frequency of replacing the batteries, what test equipment should be utilized, and some instructions there on how to get into diagnostic mode. So we have everything we need with this intelligent checklist from Pronk that allows us to follow the manufacturer's procedure without having to go and dive into the manual itself. And of course, we would follow this procedure as a technician, step by step, going all the way through. But in the interest of time, we're going to go ahead and skip all of those fundamental but important tests, just so we can get through the more more key tests that can create some confusion when you're performing them. So to run the electrical safety test, we want to make sure we hook up, of course, the ventilator over to the electrical safety analyzer. We need to do the ground resistance test on a couple of different points, including the rear of the unit. So we're going to go ahead and make sure we do those as well. And we want to go ahead and perform the electrical safety test according to the procedure. So the next step in this procedure wants us to do the earth leakage test and ground resistance test to the proximal pressure port on the front of the unit. So I'm going to take my test lead cable, connect it to here, and hit run to execute those tests to the safety analyzer. So when I do that, it's going to go ahead and start the safety analyzer, perform the test. You can see here on the app, you're going to get a ground resistance measurement. It's going to accept that result after it realizes it's stable, accepts that result, and it's going to go on and now and do the earth leakage test under normal conditions. This particular ventilator wants us to do earth leakage test in normal polarity and in reverse polarity with the neutral closed. And so we need to make sure we're running in both directions. So that's why we're doing it this way. Once that test is complete, it completes that step and we go on to the next step. The next step wants us to do the ground resistance test on the glass port. So we want to collect those results as well. So we go ahead and connect it to that and run that next test. So they want to make sure that we're testing that ground resistance on anything that in theory could come in contact with the patient. And so we want to test those ports as well. So you can see we've done that next test. It's collected that individual result. And we also need to do it on the O2 inlet, which is on the rear of the unit. So we would connect this to the back of the unit here. And then I would run that next test. And we'll get that last reading to make sure it's within the limits. Our limits here needs to be within 200 milliohms. So in this case, we're well within that limit there. We've completed those 3 electrical safety tests. So we've completed those tests. We can go on to the next test. So we can do that. So the next one is to start doing our high pressure leak tests. And we want to make sure we do those tests, of course. For the purpose of this video, we're going to go ahead and go straight over to the pressure actually test and go through that, because that involves running the Certifier Plus to perform those tests. But of course, the high pressure test is important to do. Not suggesting it's not important, but it's pretty straightforward. So we're going to jump over to do the pressure actually test next. And this starts off by wanting to make sure we record the machine pressure. We actually start with capturing the barometric pressure from the Certifier Plus. So we run that test. You can see the pressure measurement from the Certifier Plus is being wirelessly transmitted to the app. And we see that result here. We can capture that into the report. So that result is within our expected range. And now we need to record the barometric pressure on the ventilator itself. And you can see here in gray, it gives you the pass-fail ranges already within the procedure, so there's no guesswork going on here. So our barometric pressure on the vent is 734.5. So we've captured that as our reference, and we have that in there. Now we need to make sure we check our pressure at 0 centimeters of water. We need to check the average machine pressures within that range. And this is given the software revision of the ventilator, which is at 3.0. So we made sure that this procedure does correspond, that test does correspond to the procedure as we need to. So the average machine pressure at 0 is 0.24. You can see my ranges are already listed in here, so I know what's supposed to be the pass-fail range. I capture that. Go on to the next one. This one is verifying the proximal pressure value. It needs to be 0 plus or minus 1 as well. And here we're at 0.32. So we've captured that as well. And now we can go on to do the pressure accuracy test at 10 centimeters of water. And so here, we're gonna go ahead and set the pressure to 10. Go ahead and do that. And again, if you're unsure of exactly how to perform those steps, you have the instruction here that can guide you right through that. So we have that value and we have it programmed for that. We need to make sure it's within this particular range. And we need to verify that that machine pressure is at 10, and it is exactly at 10. Again, our pass-fail ranges are here. If I could enter in my value here of 10, and we finish that test. The next one is verifying the certifier pressure. That of course matches what the pressure of the ventilator is, and you can see here's our measurement from the certifier plus. That is also good, and so we have that reference captured in the report as we go here as well. So now we need to make sure we have the following step involves something that's somewhat unique to this particular ventilator, which is doing a calculation. And so the app, our checklist here, our intelligent checklist that we've created, allow these calculations to be automatically done. So this involves, in this particular step, it involves confirming the certifier pressure plus the average machine zero offset needs to be within a particular range. And down below, that calculation's already been made based on the results we previously entered. So you can see here we have a calculated measurement of 10.3 centimeters of water, which is within range. So having these calculations be built into the procedure just eliminates that manual calculations you have to do. The V60 has various calculations that have to be done, as well as some other ventilators. So the procedure really helps kind of streamline that process, minimize any errors. So now we need to record that average proximal display pressure, and we're at 10.08. And we've done that test. Now we need to verify that the adjusted pressure value, proximal value, is also yet another calculation. So this is where you're taking the average proximal at 10 centimeters of water and you're subtracting it from your average that is at 0 centimeters of water for your proximal. So this gives us a calculation that you normally would manually have to do, but the intelligent checklist we have here does that labor, that legwork for us. So you can see here that is a calculation of 9.8 centimeters of water, which is within range. That result is a pass. So now we're going to go ahead and do the accuracy test at a higher pressure. We're going to go up to 35. We'll go ahead and set the ventilator for that test. And we need to confirm the average machine pressure is within that. So we'll observe it for a moment or two. And it is right at 35.01. Capture that result. And now we need to capture the certifier, of course. We need to have a reference to what the ventilator is displaying and confirm that result. Here's what the certifier is displaying within range as well. That is a pass. We've captured that result. Yet here's another calculation that has to be done. This calculation is in reference to the certifier pressure plus average machine zero offset. It has to be within a particular range. And you can see here that it is well within that range. So we've accepted that result as well. And we now need to measure the proximal pressure as well. That is at 35.04. Capture that, and you can see there's another calculation. We've gone ahead and done that calculation here as well. So there's various calculations that have to be captured, and we've captured them all automatically via the checklist we're running here. Now we're going to do the next test at 60. Average machine pressure at 60. We'll observe it for a moment. And we'll call that 59.99. Save that. Certifier pressure at that test point. 59.89. We'll observe it for a moment, make sure it's stable, and capture that result. Again, get another calculation. The intelligent checklist calculates that for us. Well, here's the calculation within range. We capture that result. Now we'll need to measure the average proximal display, and we'll observe that for a moment, get a good measurement. That looks like it's at 60.02. Capture that. And yet, one more calculation that has to be done at this 60 centimeters of water test. Again, we have to, the formula is laid out in the procedure so you know what the calculation is based on. This is what's in the service manual itself. So we outline it there for you and then display that calculated value. It's within range, so you confirm it and accept that value. Now we're ready to go on to the air delivery test. To start off with, we want to once again take the barometric pressure from the certifier. So we'll go ahead and do that in this next step here. You can see that's what we need to do. So we'll run that and capture that barometric pressure. Make sure it's within the tolerance allowable by the service manual to run these tests. We don't want to be outside of that barometric pressure range. And next, we want to verify that barometric pressure on the ventilator again and make sure it's within range of our specs required in the manual. And it's 734.2. We'll call it 0.2. We've captured that. And now we want to do an air delivery test by converting that barometric pressure to centimeters of water. So you have to do a conversion in order to get in the right units of measure. And so you need to convert that measurement we took in step 63, which was at 731 millimeters of mercury. We need to convert it to centimeters of water. Fortunately, within our procedure here, I can find that table and find that value. So we're looking for cert 734.1, which is right in this range here. So the value we want to select is 63.12. So I've looked that up and I want to enter in here that conversion value. So I've done that, value of 731. Double check our work here. Go back to the table, 731. It is at 63 even actually, see? Good thing to double check. So we'll make it 63 even and get that into our report. Now we're going to go on to the next step, which is we also need to convert that same step that's in millimeters of mercury, 731 millimeters of mercury. We need to also convert it into liters per minute using that same information table. I want to look up 731 and it converts over to 131.99. So I'll enter that in here, 131.99. So we've captured those conversions. It'll be important for the subsequent measurements we're going to make. So now we want to confirm that the certifier pressure is higher than the centimeters of water converted value. But we need to make sure we can set up the test, the certifier to perform this test, which involves connecting our pickoff port over here so we can measure into our pressure port in the certifier flow meter. We need to connect our flow valve here as well with the filter and make sure we leave the output open. So now we want to go ahead and run that test and make sure we set it up properly. We want to go ahead and confirm that we set this up properly, and we do that by set the flow to 200 liters per minute. And so I want to go ahead and do that. And we've done that. Flow has started a curve. And now we're going to begin to close that ball valve until the pressure in the certifier is greater than the value on step 65. So we need to exceed 63. So I'm going to go ahead and do that. And I'm going to run this test. And we can see we're getting a value of 45 on our certifier. I'm going to start to close this valve. We're getting above that. You can see I got it to around 70.7 or so, higher than what I needed it to be. So I went ahead and captured that number into my report, and we completed that test. Next, we want to make sure we do the air delivery test and confirm that the value is greater in the other unit of measure, liters per minute. So we're going to run this test here and confirm that indeed it's over that value. We're at 142.29. That's over the value that's specified. We captured and completed that test. Now we can go ahead and perform the airflow accuracy. In order to do these properly, we want to make sure we've configured our ventilator properly by utilizing the plug adapter here to the bottom of the ventilator to make sure we seal that off. So that's the requirement from the manufacturer. We also want to configure the tubing into our analyzer via the filter like we have in the past. We're going to monitor pressure from the proximal port over to the flow meter, the pressure port, as well as the pick-off pressure is going to be monitored from the output here by connecting these three things together. So we've set up our Certifier Plus. As always, if you're new to doing the ventilator testing, it's been a while, always good to look at the instructions on how to set things up. You can see here we want to make sure we've set up our certifier to measure air in gas conditions STP, which I made sure to do that on my certifier ahead of time. Always make sure that we've set up the ventilator properly as well for our pneumatics. We've checked it before, but always good to check it again. Our solenoid 1 should be set to none, number 2 to machine pressure line, same as solenoid number 3, and the 4th one should be set for proximal pressure to make sure we're measuring that properly. And now we want to record the relative humidity before we start this test. Here in Los Angeles, our relative humidity today is a little bit low, so it looks like it's about 28%. So I'll go ahead and capture that in here, so we have that as well in there. Now we want to capture our temperature. Our laboratory is right at about 20.5 degrees, it looks like. So we'll capture that in there as well. So we want to do our first test at 0 and confirm that our flow is actually accurate on the ventilator when it's set to 0. So we're going to basically, we've got it set for 0, and I can see here that my value is actually at 0.1, so it's pretty much right at 0. So we'll capture that, and then what we want to do is confirm what the certifier is measuring. So we've got it connected, so we're supposed to be set for 0. The question is, does the certifier measure that same value or within its tolerance as well? So we'll confirm here the certifier, what it's measuring actually 0 as well, which is what we want to see. And go on to now, we want to set the airflow to 10. I'm going to go ahead and do that. And we're going to make sure that these tests at various flows are indeed accurate. And now we want to make sure that our actual output is actually at 10. So we can see here, I need to verify an event. It's actually set right at 10.0. I'm going to go ahead and capture that as my reference. And then we're going to confirm that indeed the certifier measures the same value. So we go ahead and enable that next test. We're measuring from the certifier here onto the app. Wait for a stable measurement, make sure there's no variations occurring, no great differences, and then that measurement looks stable. We'll go ahead and capture that and go on to the next test. So now we want to go to 35. I'll go ahead and do that. And so we're going to follow along and do all of these important tests to make sure that we get accurate results for those various tests. So at 35, our ventilator is actually putting out exactly 35. We'll capture that. And then same thing again, using the certifier to confirm the measurement and confirm its accuracies within specification. You can see here at the top, the procedure tells you what the tolerance is for that particular test. So as a technician, you always want to do your verifications. You want to utilize your skills to make sure you can verify that the device is performing properly. The intelligent checklist is really there as an aid, as a tool for you to make sure that we know exactly what are those tests we need to perform. So we'll go on to the next one. I'm going to follow the procedure, get to 60 here as well. And then I'm going to confirm on my vent, observe it for a moment, confirm the reading is consistent, and I'm getting right at 60.1. So let me make sure I'm using my keyboard properly here, get the right value entered in, and then we're going to record what the certifier is seeing once again at the various test points. So for each one, we're verifying the ventilator versus the test equipment, our certifier, and we keep going. So now we're going to go all the way up to 140. We'll do that as well. 140, we're measuring 39.2, we'll call it. Pretty accurate. Capture that result, and then once again, the certifier, what does it measure? It's measuring slightly higher, but within tolerance. We want to be within plus or minus 10.2, so well within. Now we want to remove the low pressure plug. And then record what that value is. So now we want to remove this pressure plug from the bottom of the unit, and we'll see that the flow just dropped slightly, but it shouldn't drop out of specification. So we'll go ahead and remove that. Bear with me 1 second while I do that. A little tricky to do this with the ventilator horizontal. Okay, you can hear that the flow changed slightly. So now I want to capture and see what the certifier measures with that plug removed. And we should be over 90 liters per minute, and we're at 126. So that's good, but I needed to make sure I set the vent to 120, which I still have it set to 140, so I'm going to go ahead and do that. You can see here why it's helpful to have the instructions here side by side to make sure we don't miss a step. The instructions here clearly tell us to set it for 120. So we'll confirm it. So at 120, I need to be over 90. So I've confirmed I've set it to 120. I've removed the plug, and I want to confirm that I'm seeing at least 90 liters per minute. And of course, we're measuring 107.66, well within specifications. So next, we need to do our O2 mix accuracy tests. And to do this, we first need to do a oxygen not available test. It's a safeguard test to make sure that the ventilator can detect that oxygen is not coming in, so it's important that we do that. And it requires us to connect the pick-off valve to it and connect it to the proximal pressure port and to run that test. And to do that, we need to follow our instructions, which we have available here, and configure the ventilator for these settings. So you want to set flow, you want to be in ST mode, set the IPAP, EPAP to these values and the rate. And then you want to set your alarms accordingly to the procedure. And the point is to verify that the ventilator does trigger an oxygen not available alarm. So it's critical that we do that. I've gone ahead and do that, but I wanted to explain it to you that that's what this next test is. Once we've completed that test, which we've done, we go on to do the O2 mix accuracy test. And to do that, we need to configure this differently, of course. We can take this pick-off valve, connect it to the output, connect this over to here, connect our ventilator to the proximal pressure port like we had before. So let me do, we had it here. And then of course the other end, we connect the pressure port to our pick-off valve here at the output as well. And you probably noticed that now in line here, we have our oxygen sensor connected to the circuit. So this is what we're going to utilize with the FA Certifier Plus flow module here to measure the oxygen concentration. So let's go ahead and connect this up to it here. And we've got it configured properly. Again, always making sure there's no leaks in the system. You've got it set up optimally so we don't have any errors in our measurement. And we also want to make sure we've configured our certifier properly. Again, if we go back to our instructions, you can see here it wants to make sure we've set up the certifier for measuring air in O2, which I've done as well. Set it up for gas conditions STP and configured my waveform ports accordingly. And then we also want to now go into the service mode again of the ventilator to do the subsequent tests. So I'll go ahead and do that real quickly. We'll get that set up into service mode. And we now need to configure these settings, going into the pneumatics menu, and we need to configure this flow. So we want to set the pressure to 0, set our flow for 10. Go ahead and do that. Get some flow occurring here. And we want to set our O2 set for 21%, which it is. Again, you want to confirm your solenoid configuration, which is labeled here at the bottom of the procedure. And we've done that, and it is correct. So we'll go on to the next step. So now we want to see what our O2 mix is at this percentage and make sure that it's correct. So let's see what the concentration value is the certifier measures. So the certifier is measuring this. Of course, you want to make sure you've You've calibrated your oxygen sensor for the right oxygen concentration. If it's a new sensor, make sure you've done that ahead of time in your analyzer in order to get the accurate measurements. So that's within tolerance here. Now we want to go ahead and now change that oxygen mix. We want to increase that to 30% and confirm that indeed we can measure that properly. So we've set that. Now we're going to see if the certifier measures that percentage accurately or not. So we'll give it a moment for it to rise. Give it enough time to make that sample. We want to make sure that the oxygen concentration is at 30% plus or minus 4.4. So you can see it takes a couple seconds for it to sample and get us a stable measurement. And now that we've seen it, it's stabilized really right at 30.1, well within the tolerance. So we're confident with that result. Go on to the next value. And we want to again now do it at 60%. So now we'll increase it to 60% and do the same thing. So you always want to make sure you follow the instructions, run the test. You have your tolerances and your test point listed. Here's another reference. As we're doing a lot of these tests, it's easy to think that we remember or recall all of the values. So it's really helpful to have the procedure there in front of us, guiding us all the way through. So we can see here as the oxygen concentration is flowing, it's increasing. We'll wait for the measurement to stabilize, to also confirm that the value does not fall out of tolerance as required by the manufacturer. So we'll give it another moment or so to make sure that that oxygen concentration value is stable. And you can see here we're right at almost 59, still within tolerance. It's holding stable, not dropping or varying in any way. So feel confident it's working properly. We can capture that result. So our next test is to do it at 100%. So we'll go ahead and set the ventilator for that, and to make sure that we're doing and passing that test. So we'll go ahead and do that. We'll go ahead and make the measurement. Just like the others, it takes a moment for it to ramp up its output to 100%, but we want to make sure we get to 100% plus or minus 3. So we need to get over 97 and make sure that it's within that limit. And so we'll wait for it to stabilize. You can see here we're on the lower end, but we are within the pass-fail limits within the procedure. So we'll wait for that to stabilize, make sure it stays consistent. And it looks like it is. So we'll capture that result, pass it, go on to the next test. So the next set of tests we need to perform are the ST performance tests, or the spontaneous trigger test, verifying various modes of the ventilator that it's functioning properly when it's programmed to deliver ventilation to the patient. For these tests, we need to configure, of course, our analyzer properly by connecting the output over into our tubing here through our filter into the flow meter, making sure we're connecting our proximal pressure port into our analyzer as well, and also connecting a pickoff port on the output so that we can measure that pressure. And now we want to connect the output hose to a resistance set at a value of 20 centimeters of H2O connected to our test lung. So we need to make sure that's set up properly. Also connecting it via a whisper swivel that we connected from the output into that port here, so that we have this configured properly per the manufacturer's specifications. So we need to make sure we've set that up properly so that we get the proper measurements. Again, the instructions are here as well. You can follow them step by step through, and we need to make sure we've done that and set that up properly. We want to go ahead and now turn on the ventilator and program these settings you see here so we can perform our tests. So we're going to do some flow tests by basically setting the IPAP, the inspiratory positive airway pressure to 15 centimeters of water, which is already set for. The EPAP, or expiratory positive airway pressure, set to 4 centimeters of water. Our rate to 12 beats per minute, breaths per minute. The I time at 1 second, the rise time at 2, with an oxygen concentration of 21%. Then we want to set our alarm limits as well. We have it all configured properly. We've got our system set up properly here as well. You also want to now connect the trigger cable, TTL trigger cable, from the back of the ventilator. It's a special cable you have to make sure you connect from the back of the ventilator. It's got a 25-pin port there, and it connects to the certifier flow meter so that it could trigger the measurement properly. So you need to make sure you've set your analyzer to trigger at TTL high so that it can make that measurement at precisely the right timing. So you've got that configured properly. We can go ahead and finish this setup and perform the test. So the first test we want to do is to perform this test at a EPAP of 15, and we want to make sure that the value is within plus or minus our tolerance here. So we're going to go ahead and run that test. We've got it set for 15, and we're going to make sure we measure our peak inspiratory positive airway pressure at 15 plus or minus 1.4. We're pretty close here. We'll watch it, monitor it for a moment, make sure it stays within tolerance. We don't want to take a momentary value. So in observing it, it looks pretty stable at that value. We're going to go ahead and capture that value, that test pass. And at the same time, we want to verify our PEEP. Our PEEP value is within the right tolerance. It should be within 4 plus or minus 0.3. And you can see here we're at 4.2. That is within tolerance. We'll monitor it a little bit longer, see if it stays stable. We'll want to make sure that peak value or that peak end expiratory pressure stays within that limit. And it looks like it is. We'll go ahead and capture that value. Next, we want to now program it for a IPAP of 40. And so we're going to go ahead and do that. And we'll go ahead and set that up now. So we're going to increase this to 40. And we're going to set the EPAP to 25. And we're going to confirm that the PIP value is 40. So we'll wait a moment here for it to kind of reach that peak pressure. And right now it's set to, my analyzer is set to average based on 5 breaths, an average time of 2 seconds, which is also a requirement in the service manual. So we've also configured the sampling of the breaths for every 5 breaths. That's why it takes a little bit longer for you to get an average. As you see here, the average is now coming in within specification. Again, it's to make sure that you're not taking a momentary reading. You want to make sure you're taking a good long average to make sure your value is truly within tolerance. And you can see here, it's pretty stable now. We're going to capture that value. Now we want to verify our PEEP as well is at 25 plus or minus 3 to make sure that peak end expiratory pressure is within that tolerance. And we can see here that it's been running for a moment, quite a while now, and it's holding within tolerance. We'll monitor it a little bit longer just to be sure, but we can see here that peak value is within tolerance, and that value does pass. So we finished that test.
Great. So you could see quite a number of tests to do on a ventilator, as I'm sure you have done many, many times. We want to kind of cover a couple other tools that we think could be beneficial as we're servicing ventilators. One is having access to the MOD database. It's a database available to us all. There's a link here at the bottom that lets you see any incidents, any issues reported on any kind of FDA regulated device out there. So this allows us to look at incidents reported to the FDA, any machine failures on any kind of device. It could be a really helpful tool if you're trying to investigate or considering purchasing ventilators for your facility to kind of see what the history has been service-wise. Also want to cover a couple of incidents that I thought would be good to refer to as a reference as we're out there servicing ventilators. These are actual FDA reported incidents that I've kind of summarized here. This one case here unfortunately resulted in a patient death where the clinician went into the room and the ventilator was alarming, and the manufacturer, what they call narrative here, investigation, it's been kind of summarized here a little bit, highlighted in yellow. The technician could observe that they found foreign particles of external environmental origin inside of the blower inlet, the blower bellows, and inside the transition tube of the flow path. So clearly there was foreign debris coming into the unit. They concluded that the root cause of this failure was due to a missing porting block adapter caps. This particular ventilator requires you to install porting blocking adapter caps in a particular configuration. And because these caps were not installed, unfortunately, ingress of debris got into the ventilator and caused the problem. So these is just an example of some issues that can happen and why it's important that we make sure we don't miss any steps when we're out there servicing ventilators, because some of these steps can be very, very critical in the performance of the device. One more incident, we have an issue here where the PEEP pressure, the positive and expiratory pressure, was increasing on the patient to the point where the patient experienced a collapsed lung, basically, and unfortunately the patient expired. Again, they did the investigation. They could see through the logs that the pressure, the PEEP alarms were sounding, so letting the clinician know that there was alarms that were occurring. They could see the trend logs that the pressure, the PEEP pressure was increasing and increasing, and there was an indication that there was some kind of clog in the bacterial filter on the expiratory side. They did conclude that the ventilator did not have any malfunction. So technically speaking, the ventilator was performing properly. It was alarming properly. But unfortunately, because they missed where a bacterial filter became clogged on the expiratory side, it built up that PEEP pressure and caused harm to the patient. So many other examples you could find there, not to critique anything or any device, but something that we always can take and learn from. So we definitely are very focused and interested in continuing to partner with our HTM community to provide solutions that benefit you all. We're going to continue to develop additional what we call mobilized checklists for other ventilators, other kinds of medical devices, not just ventilation, but other types of devices that can be utilized with our products and other test equipment partners that we partner with, like an example here where we partnered with TSI to connect their ventilator analyzer to our platform to help automate and help the testing of these critical devices go more efficiently and more accurately as we're servicing them. And of course, the advantage of having an app platform like ours is you can as we add more features and capabilities, they'll be pushed out to the field as regular updates. There's no extra cost as we add more automation capabilities to our platform. Of course, there's no monthly fee for the app. It's available on the App Store now. You can go there and download it and utilize it and take advantage of it with our products and our test equipment partners as well. So of course, we are working on other platforms. We're focused on the Apple iOS version, but we are working on Windows and Android as well. So very important that we continue to hear your feedback and input on what we should work on next and what we can do to help improve and make a little bit easier just the difficult and challenging job you have out there. So we appreciate and continue to support everything you do, and we appreciate any support and feedback you can give us on what we should work on next. Okay.
Perfect. Thanks, Julio. That was great. We have actually got loads and loads of questions, which unfortunately we won't get time to go through. So I will start with a couple, and then to the attendees that have sent in so many questions, I will send them to you, Julio and Jeff, so you can answer offline at your own convenience, okay?
Thank you.
Okay, we'll start with the first question then is, can I use the PRONC created procedures with other brand flow meters and safety analyzers?
Okay, so the PRONC created procedures are designed to work with the mobilized Bluetooth PRONC devices along with partner devices from defib analyzer companies and from flow analyzers as demonstrated. So primarily you have to use the PRONC device with a Bluetooth. If there is not a device available in your inventory, you cannot take advantage of the automated features, but you can manually input information into the checklist.
Do you want to add to that, Julio, or do you want me to go on to the next question?
Your audio cut out, I think. I didn't hear the second question.
Okay, I'll move on. I'll move on to the second question. It's how do the trigger settings on the analyzer impact the ST readings?
Okay, so the trigger settings, referring to the TSI certifier, has to be set to a positive edge trigger, and this enables the certifier to pull in information on the expiratory end cycle of the breath. So by changing it from a 0 to a positive trigger, that allows or indicates that the breath change at that point is indicating that is time to pull that breath cycle on there. If you have it at 0, it'll continue to only pull inspiratory. It doesn't detect that there's a change.
Okay.
Are you able to hear just
Another question here is, sorry, Julio, carry on.
I just wanted to confirm you could hear Jeff's responses.
Yes, I could. Yeah. Okay, I'll go on to another question. This V60 procedure wants the averaging to be set at 5 breaths, which of course takes longer to see the correct values. Are there situations where I should set the averaging to a lower value?
So in this specific procedure, the manufacturer calls out to take the 5 breath average. And of course, we want to follow what the manufacturer's guidance is in the procedure. If you lower the breaths, you'll get a quicker response back. It depends on how comfortable you are with the ventilator and the readings that you're getting. You could lower the amount of breaths, which would give you a faster result. And as long as you're seeing consistent values on there, you always want to validate that against the manufacturer saying. It's really individual choice and comfort with testing the ventilator itself.
Okay, perfect. Well, we're coming up to the hour, and as we are having a few audio issues, we'll wrap up now. So thank you, Julio and Jeff, for your time today and for a great presentation. I'd like to encourage everyone to visit today's sponsor to learn more about the services they provide to the industry. So please visit prog.com. As promised, the answer to today's trivia question is ranch dressing. So congratulations to our winner, Andrew Warren in Florida. So enjoy your gift card. Just a quick reminder, you can obtain your CE certificate by completing the post-webinar survey, which will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your 1 CE credit from the ACI, and you'll be able to download the certificate directly from your computer once the survey is submitted. Again, if you have any questions, you can reach us at webinar@mdpublishing.com. If you've missed any of our past webinars, including any by prompt, please visit webinarwednesday.live to view our whole webinar archive. We'll be back next week with another webinar and another 10th anniversary prize, so please visit webinarwednesday.live for more details and complimentary registration. Thank you once again for your time today, and I hope you all enjoy the rest of your day.